Hi students, we're going to continue in line and planes video part 2. Before we talked about equation of a line, now I'm going to talk about equation of a plane. Suppose you have a plane here P and the point P0 belong to that plane, and suppose this plane has a normal. Normal, it means perpendicular to a normal line N. We want to find the equation of the plane. So what I'm going to do, let P, X, Y, Z be any point on that plane. It's varying on that plane. So as P is varying, since N is orthogonal perpendicular to the plane, so N is perpendicular to every line inside the plane. Every line inside the plane, because N is perpendicular to the whole plane, especially P0P. So because N is perpendicular to the plane and perpendicular especially to P0P, so the scalar product here must be 0. You know the scalar product of two orthogonal line is 0. So I need to find the components of P0P, so it will be x minus x0, y minus y0, z minus z0. And the normal of line N, suppose it's given ABC. Since they are orthogonal, so we're going to say the product x prime plus y prime plus z prime is 0. So if you expand this one, you're going to get ax plus by plus cz, where variable x, y, z equal, if you take the numbers to the other side, the coefficient x0a plus y0b plus z0c. This constant, I'm going to name it big D. So from now and on, equation of a plane is always of the form ax plus by plus cz equal to d, where coefficient of x, y, z, a, b, c are the components of a normal vector, any normal vector to the plane, and where d is a constant. To find d, you need a particular point, as we said. You replace it here to find d. So let us take example, but most important to know that the equation of a plane is ax plus by plus cz equal to d, where a, b, c are the coefficient of a normal of the plane, any normal. Here, find the equation of a plane passing by point A and normal. Since this is the normal directly, the equation will be 5x plus 2y minus z equal to d. I need to find d, so I replace a in the equation of the plane. So here I put x is minus 3, y to be 0, and z to be minus 7. If you solve it, you're going to get d minus 22, and the equation of the plane will be 5x plus 2y minus z equal minus 22. Now I want to find an equation of a plane passing by 3 points, point A, point B, point C. To find the equation of a plane, I need to find its normal. So here it's very simple to find a normal if you have two lines inside the plane. You just do the cross product. We know from before, if you have two lines, two vectors, for example, if you do the cross product, you get the vector perpendicular. And since these two planes, two lines are inside the plane, so it will be the normal of the plane. So I have line point A given, point B is given, and point C is given. So what do I do to find the normal vector, which is this black vector? I do AB cross AC. So AB, I find the components, and AC, I find the components. So if you have these components, you can check. So I do AB cross AC, IJK, AB and AC. I do the product. I'm going to get the normal vector, which is 3, 2, 6. Since I have the normal, so the equation will be 3x plus 2y plus 6z equal to d. I need to find d. I have three choices. Either I replace by A, or I replace by B, or I replace by C. So if you replace by B, for example, because I have two zeros here, just I put mahal instead of x is 2. So I'm going to get D is 6. This will be equation of plane P. There is another way we can find it, method 2. It's up to you to decide which method. If you do AB cross AC, you're going to get the normal. If M is any point on the plane, you know that AB cross AC is a perpendicular, and since this normal is perpendicular to the whole plane, with the scalar product with AM will be 0, because as we said, let M be any point on that plane. So the box product that we talked before about in the previous videos will be 0. always when you want to find an equation of plane, you must pick, for example, in this method, and any point moving on the plane whose components are x, y, z. AB cross AC, because AB and AC are in the plane, so it will be the normal vector. Dot AM, and because perpendicular to the plane, so it's orthogonal to every line inside the plane, especially what AM. So if you do it, AB cross AC, this is AB, this is cross AC, the box product AM, so XM minus XA, YM minus YA, so Y, ZM minus ZA, so Z plus 2. If you do now the box product, you're going to get this answer, okay? So it's the same equation as we did before. Either you have method 1 or method 2. Now I want to find the equation of plane Q, find a plane parallel to the plane Q and count. Because parallel, two planes are parallel. Certainly, if you have a plane here parallel to a plane here, they have the same what normal. So I'm going to use the same normal, 2x minus 3y plus 2z equal to d. To find d, because the plane is passing by A, I replace it here. D in that case will be 3. Write the equation of plane containing the point A. This is the point A here. This is the point A. And containing this line. Because it contains this line, I know that I know the directing vector of the line, which is 3 minus 2 minus 3. This is the directing vector. You know, it's a vector parallel, for example, to the line. And you can take a particular point here. I name it to be B, whose components are what? 2, 1, 2. So I have a point, I have point, and I have directing vector. So I need to find first of all the norm. So to find the norm, what do? I do AB cross D. D is the directing vector of D. AB cross D, it will give me the norm because these two lines are inside the plane. If you do the cross, will be perpendicular line to the whole plane. So I do AB cross D. Components of AB, if you do AB, 2 minus 3 is minus 1. 1 minus 2 is a 3. 2 minus 2 is 0. And the dot of the directing vector is 3 minus 2 minus 3. So you're going to get the norm. And I need to find D to find, because these are the components of the norm, so 9 minus 9x minus 3y minus 7z equal to D. And to find D, either you use point A or you use point B. Here I have used point A. You get D, you can find the equation. Another way, you can say, for example, since I want this equation, let M be any point. I do AB box product, AB cross D. You're going to get this norm times what? The scalar of BM, for example, or AM, whatever you want. It will be 0. Why? AB cross D is a vector perpendicular to the plane, and AM, this is M, for example, is a line in the plane, because orthogonal to the plane, it's orthogonal to every line in the plane. So if you do the scalar product, it will be 0. So AM, these are the components. AB, these are the components, and these the components. If you do now the determinant, you're going to get the same equation as we got it out. More examples. Find the equation of a plane containing the two intersecting lines. I know that these two lines are inside, so no need to find point of intersection. Why? Because I can pick a point here, I can pick a point here. I have the directing vector of this one and directing vector of this one. So I have everything I need. You have point A, 2, 1, 2 in this first line. You have its directing vector. You have a point here and directing vector. Okay, so you can say, for example, if I want to find the norm, I do directing vector of the first plane cross the directing vector of the second plane. Okay, you're going to get the norm. D is 3 minus 2 minus 3. D prime is 3 minus 1, 5. So if you do it, you're going to get the normal vector. So this is the equation of the plane. I need to find D. Either you replace A here or you replace B. It's up to you. If you do, any one of them will give you this. D is minus 44. So this will be the equation of the plane. I'm giving you all kinds of equations so that everything will be simple for you. Relative position of two planes. Either two planes are parallel or two planes in the same plane, or they intersect along a straight line like this one, parametric equation. So how do we know? If you have this equation, if a over a prime equal b over b prime equal c over c prime equal d over d prime, so they coincide, the two planes same. If a over a prime equal b over b prime equal c over c prime, but not equal d over d prime, it means they are parallel. If a over a prime not equal b over b prime, not equal, for example, any of the two equalities are not correct, so we say they intersect. And how do we find the intersection? We put let z equal to m. We solve two equations to unknown. We're going to see in an example. It will be very simple for you to understand it by example. Here I have three examples. Study the relative position of the two planes. I have these two planes. As you can see, minus 6 over 2, 9 over minus 3, minus 6 over 2, minus 12 over 4, all are equal to minus 3, so the planes are the same. Here, minus 6 over 2 equal 9 over minus 3. It's the same, equal minus 6 over 2. So till now, it's parallel or coincide. But since not equal minus 12 over 5, so we say the planes are parallel. In the third one here, since minus 3 over 2 is not 2 over minus 3, so the planes are neither parallel nor coincide, so they are intersecting. How do we find the intersection line? So I say let z equal to m. So you're going to get 2x minus 3y equal 4 minus 2m, because z is m. And in this other one, minus 3x plus 2y equal minus 1 plus 6m. So I have two equations to unknown. Let us start by canceling x. To cancel x, I multiply up by 3 and down by 2. If you multiply the whole thing here by 3 and the whole thing by 2, these two cancel out. You're going to get 5 minus 5y equal 10 plus 6m. So if you want to divide, take minus 5 to the other side, this will be y. This is the parametric equation of y. This is parametric equation of z. Now you can replace y here, or you repeat it. You cancel now y. I multiply up by 2 and down by 3. If you multiply the whole thing by 2 here and the whole thing down by 3, you're going to get that this is x. So what is the line of intersection? X equal minus 1 minus 14m, y equal minus 2 minus 6 over 5m, and z equal to m. I have certainly may get infinitely many points of common, minus 1, minus 2, here you can say plus 0, or you replace m by any value, you get another point. And this is the directing vector of the line of intersection, minus 14 over 5, minus 6 over 5, and 1 here. So this is the only way to find the intersection between two planes. Relative position of a line and a plane, it's very simple. Either they intersect or parallel or inside. Let me to go directly. You can read this one because I don't have enough time. I need to finish. So let us read it directly. Find the relative position of a line and a plane. So if you want, what do? You replace here x, you replace y here, you replace z here. If you solve, you're going to get, for example, 0t equal to a number which is not 0. It means impossible. The lines are parallel. If you replace here the same x by value, y by value, z by value, you're going to get 0 equal to 0, infinitely many solution. It means the line inside the plane. If you replace here x, y, z, if you like this one, you're going to get a value of t, so they intersect. And to find the intersection, you replace t by minus 3. You're going to get 2 minus 6, 1 minus 8, 2 plus 4. You're going 2 plus 6, sorry, it will be 8. This is the point of intersection. This is between a point and a plane. In the book, you're going to see something more complicated, but I'm going to give you a very simple way you can use it. If you want to find a distance from a point, you have a plane, P, and you want to find the distance from a point, you draw the perpendicular. To find that distance, what do? Let us take example. You take the plane and you equate it to 0, and you bring this 2 here. So you're going to get 2x minus 3y plus z minus 2 equal to 0. What do? The formula of the distance, you do absolute value. You replace x by its value, y by its value, z by its value. Over square root, you take the norm of the vector and you square it, a squared plus b squared plus c squared, so 4 plus 9 plus 1. So it's very simple, it's just a formula. In the book, you're going to see one more difficult. And if you want to find the angle between two vectors, you just do what? the cosine rule. You have the norm of the first vector, the norm of the second vector, you know the scalar product, and 1 dot and 2 is equal norm and 1 norm and 2 times cosine of the angle in between, the ordinary one. If you do it, you can find the answer. I hope that you got everything. This was the vector, and see you.